You plan to purchase an investment that will pay $1,200 at the end of each year for 10 years. However, the first payment will not be received until 5 years from now. If the interest rate is 6% compounded annually, what is the present value of this deferred annuity today? So the annuity starts out today, and it makes 10 years worth of $1,200 payments. The first payment is 5 years from now. So the first payment is right here. Now, if we pay attention to the question, it says that the payments are made at the end of each year for 10 years. So this first payment, well, it's made at time 5 years, it's at the end of year 4. So it'll go from the end of year 4 until the end of year 14. We could also think of that as the beginning of year 5 to the beginning of year 15. So there are two perspectives on this, and whether you treat this as an annuity or an annuity due really depends on where you put that present value. So we need to eventually bring it back to today. The two formulas that we have bring it back to either 5 years, which would make an annuity due, or to 4 years, which would make it just a regular annuity. I'm going to bring it back to 5 years. This is going to make it an annuity due because annuity dues have their present value underneath their first payment. So in this instance, if we call this the first calculation, that'll be our present value of the annuity. And then we're going to bring that back 5 more years to today. That'll be our second calculation. This one is an annuity due. This one is compound. Because we're making no payments, we're just moving a lump sum of money, this money that's in box number 1, over to box number 2. So if I look at the calculator values, I'm going to have 2 different calculations. I'm going to do this all by calculator, just to make this easier on myself. I'm going to make 10 years worth of annual payments for my annuity. So my N here is 10. For the entire question, the interest rate is 6. The present value in this case is unknown. The payments are $1,200. Future value is 0. My payments per year, I'm making 1 payment per year, and I'm compounding 1 time per year. And I'm in beginning mode because my present value sits underneath my first payment. Now for my second calculation, this compound part, I'm going 5 years, 1 compound per year, so a total of 5 compounds. My present value is unknown. My payments are 0 because I'm not making any periodic payments during that time. My future value is this amount here. So it's actually this amount that I'm going to have is my present value. In a compound interest problem, my payments per year have to be the same as my compounds per year. I'm compounding 1 time a year. and the mode doesn't matter. So that's my plan. I'm going to find my present value here, and then that's going to give me my present value here. So for calculation 1, 10 and then n. 6 is my interest, 0 is my present value, $1,200 payments, 0 future value, 1 payment per year, 1 compound per year. I'm in beginning mode. I'm going to compute my present value. And my present value, I'll put it over here, is $9,362.03. Because I'm reusing that as my future value here, I'm just going to hit future value on that. Now, I need to change my n to 5. Everything else stays the same. And so now I can compute this new present value. And I have PV2. I've got to change my payment here too. I have my PV2 equal to $6,995.85. Now I almost messed that up by not changing my payment over. So make sure that you get all of those changes incorporated into your calculation. So at 5 years, I have that 93.62 in my account. That comes back using compound, and I've got my 69.95 here. So my final solution, what's the value of this deferred annuity today? It is $6,995.85.